Students, this video is going to go over mathematical proofs, and we're going to do an introduction to it with the mutilated chessboard problem. So first we need to talk about the difference between scientific proof and mathematical proof. So generally, scientific proof observes something. This might be birds, it might be observing something under a microscope, it could be the laws of physics that they're observing. But they observe and formulate their hypothesis of how they think things are working in that system. They test a hypothesis repeatedly, and the hypothesis is considered proven until a counterexample is found. So a quick example would be, by first observation, it does look like the sun goes around the Earth instead of the Earth going around the sun. But as astronomers tried to plot the orbits of the planets, they saw that things weren't lining up the way they should, and they had to change their model. The same thing. They thought the planets were going in circular orbits, but that just was not following the path that they were seeing with their telescopes. They had to modify their hypothesis, and we found that we're using elliptical orbits. Mathematical proof's a little bit different. They start with a true statement, follow with other true statements, and since one true statement implies the next, which implies the next, and so on, if all statements are true, you have to agree with the conclusion. Okay? So the way this works is lawyers try and do this in court. They start with a true fact, and they say, well, based on this, we also know this. And based on that, we know this. And based on that, we think that this is true. The difference is mathematical proofs usually use numbers or use logic that cannot be broken down or refuted. So if a mathematical proof is good, it stands the test of time and is going to be true for all of time. So the mutilated chessboard problem goes like this. Your standard chessboard has an 8x8 configuration with 64 squares. If we took one domino, that should cover 2 squares. Okay, so if a domino covers 2 squares, it would take about 32 dominoes to cover the entire board. Not about 32, but exactly 32 dominoes to cover the entire board. If each domino covers 2 squares. And we're not going diagonal or anything weird. Just covering 2 squares at a time, you would need 32 dominoes. Now, what if we removed the 2 opposite corners from the board? So if we took out those 2 white squares from the board, what we would have now is a situation where there are only 31 dominoes required. This is because it's one less domino than before. But is it even possible? That's the question. Now think about that for a second. Maybe it seems obvious, sure. I'm sure it's possible. But is it possible? A mathematician wants to either prove one way or another, yes, it's definitely possible, or no, it cannot ever be done. So feel free to pause here and grab a chessboard and 31 dominoes and try it for yourself. Of course, I'm just kidding about that. So we have to have some other method. Okay? How do we prove it can be done or cannot be done? Well, on the left side, you have someone who says, I've tried 1,000 ways and all have failed. And on the right side, you have someone who says, well, maybe there's one you haven't tried. And that can be extremely frustrating. Now, if the guy on the left says, well, I wrote a computer program and it tried every possible combination. Well, the guy on the right said, well, how do we know your computer program is flawless? How do we know it didn't make a mistake? And this is why we need mathematical proofs. So, a proof without numbers, that's what we're going to try and do here. So there's a variety of methods for proving something mathematically. The methods usually involve numbers or diagrams. Okay, so for example, the Pythagorean theorem is an example that would definitely benefit from a diagram. Proving the quadratic formula is something that mainly uses pushing around some algebra and some variables. We're not going to do with any of that. Here's what we're going to use. We're going to use a statement of logical facts. So let's start with some facts. Both squares that were removed from our board were white. So there's now 30 white squares and 32 black squares. See if you agree with that. Before it was 32 and 32, but we took out 2 white squares, so now it's 30 and 32. Second fact, each domino covers adjacent squares, And adjacent squares are always opposite color. On a chessboard, it's black next to white, next to black, next to white. It goes black, white, black, white, black, white. Okay? So, no matter how they are arranged, the first 30 dominoes will cover 30 white squares and 30 black squares. Think about that. That means there's always going to be 2 black squares remaining. Okay, since we covered 30 whites and 30 blacks. But we stated in the first statement there were 32 black squares. So there must be 2 black squares remaining. Okay, what's the problem? The problem is those 2 black squares cannot be side to side. Nowhere on the board do you see 2 black squares or two squares of the same color side by side. So the last domino cannot possibly cover both of them. So you'll never be able to cover all the squares since 1 black square will always be left over. Ta-da! You've just done your first proof. Alright, now if that seemed a little confusing, you can go back, see if you can find anything you disagree with in any of those steps, any of those facts. There's just 6 facts, no numbers other than the 30 and the 32, and that's it. So if you can follow that logic and you agree with it, then you have just proved it. That is logical proof, and I hope that gets you a little bit inspired to see that, not all proofs have to be bad and not all proofs have to be some scary stuff at the high calculus level that's overwhelming. So thanks for watching. See you next time.